7.2, graphing rational functions. So, we probably need to talk about what a rational function is. But before that, we're going to talk about this weird-looking word that you guys probably don't know how to pronounce yet. It's called an asymptote. An asymptote is a line that a graph approaches more and more closely, but the line and graph never meet. So I have a line on my graph, and the graph, the curve, is going to gradually get closer and closer and closer to that line, but it's never, ever, 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 ever going to touch it. It just gets exponentially closer and closer and closer, but it'll never touch. That's what an asymptote is. Okay? A rational function has the form f of x equals p of x over q of x, where p of x and q of x are just polynomials, and q of x does not equal 0. We talked about inverse variation yesterday. The inverse variation function, f of x equals a over x, is a rational function. So the inverse variation function we talked about yesterday, y equals a over x, or f of x equals a over x, is a rational function. The graph of this function, when a equals 1, is shown on the next slide. Any questions so far? Yes, no, maybe so. Can I move on? Okay. So, when a equals 1 for that inverse variation function, that is the graph of my parent function for all of my rational functions. The graph of the parent function f of x equals 1 over x is called a hyperbola. Not hyperbola, but a hyperbola, which consists of two symmetrical parts called branches. So if you look to the right on the screen, this is one of the branches, this is another branch, and they're symmetrical. They're folded over this y equals negative x right here. Symmetrical across that line. Does everyone see that? That's called a hyperbola. The domain and range are all non-zero real numbers. So the domain is the set of all real numbers x, such that x can't be 0. Because if you notice, we have an asymptote, horizontal asymptote at y equals 0. This curves out, flattens out at 0, but it's never, ever, ever going to touch 0. It's just going to gradually get closer, 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 but never touch it. So we have a horizontal asymptote right here. Does everyone see that? So my domain, well, domain's left to right. I've got to also have a vertical asymptote right here, though, of x equals 0. So going from left to right, it's going to hit every single number except for 0. And then after 0, it's going to hit every other number also. So it's all real numbers except for 0. Same thing with my range. My range is looking at the y values. This is what I was talking about, the horizontal asymptote. It's going to hit all the numbers except for 0. It's going to flatten out at 0 but never touch it. So domain's all real numbers except for 0. Range is all real numbers except for 0. Any function of the form g of x equals a over x, where a does not equal 0, has the same asymptotes, domain, and range as the function f of x equals 1 over x. You need to know that. If I get any function that's got any number just over x besides 0, it's going to have the same asymptotes, same domain, and same range as 1 over x. The asymptotes will be at x equals 0, y equals 0. Domain and range will be all real numbers except for 0. Okay? Any questions about any of that? Good?
No.
Okay, I'll give you a little bit to write this.
touches those other lines?
Yep.
How? Isn't it always getting closer?
Always, but never
How's it
touching.
not gonna ever touch?
It's mind blowing, isn't it?
Well, tell me why.
Do what?
Tell me why.
That's what we define as an asymptote, and the hyperbola will just never cross over that line. It's gradually getting closer. It's like if I keep dividing a number by 2, it's never going to hit 0, is it?
It could.
No. It's not going to ever hit 0. It's just going to gradually get closer to 0, but it's never going to get to 0. Same concept here. This line is just gradually getting closer to that line, but it's never going to touch that line.
That shouldn't be like that.
Okay. Sounds good.
We need to rethink that.
I mean, if you want to graph it all the way to whatever x to the 2 billionth, or when x equals 2 billion, you can plug that in if you want. It won't be 0, though. You'd get 1 over 2 billion, which is not 0. Can I move on? Okay. It says graph g of x equals 4 over x. Compare the graph with the graph of f of x equals 1 over x. I could probably compare it without even graphing it, but let's graph it and see what happens. So hit on and the y equals button. And y1 equals, type in 4 divided by x.
What the heck?
What?
I got it.
Did you get it?
Yeah.
Did you get a hyperbola?
I got the, yeah, I think so.
The 2 branches, symmetrical branches?
Spider-Man. Oh, well, not anymore.
So you should be getting something. Oh, I can't draw up here. What am I doing? Should be getting something along the lines of
Why can't you draw on the board?
when my iPad's hooked up to it, I can't draw it up there. So that you should be getting something along those lines. Okay? How does this compare with the graph of y equals 1 over x? Well, what does that last paragraph tell me?
Well, it says that any function of the form g of x equals a over x.
Okay? Is our function here the form g of x equals a over x, where a does not equal 0? Yeah, so it does take that form. So what do I know is going to be true of it?
It should have the same asymptotes,
Same asymptotes,
domain,
same domain,
and range.
and same range as 1 over x. Is that the case? Do we have a vertical asymptote at x equals 0? Yeah. I do want you guys drawing the asymptotes whenever you are graphing these. Do I have a horizontal asymptote at y equals 0? Yeah, I do. Is the domain all real numbers except for 0?
Yeah.
Yeah? Is the range all real numbers except for 0? Yeah, so that'd be me comparing this graph to 1 over x. I would say they both have the following. Horizontal asymptote at y equals 0. Vertical asymptote at x equals 0. Domain goes from negative infinity Actually, I'll say domain and range. Go from negative infinity to 0, and then from 0 to infinity. That'd be me comparing the graph of 4 over x to the graph of 1 over x. Does that make sense? So whenever you're drawing your graphs on your assignment, we're going to find out how to get our asymptotes in a little bit when they're not 0. But I want you to draw your asymptotes correctly. I want accurate asymptotes. Then you're going to type it in your graphing calculator and you can just sketch in the branches. You don't have to get the branches perfect. But I do want your asymptotes perfect. Okay?
And that's the answer?
Yep. I graphed it, and now I compared the graph of 4 over x to the graph of 1 over x. Does that make sense? Which, like we said, we already knew it was going to have all this stuff because it told me any function of the form a over x, where a does not equal 0, has the same asymptotes, domain, and range as 1 over x. Okay? Questions on example 1?
Yeah. So what's the answer supposed to be?
The graph,
Yeah.
and then
All that?
all that. Okay? Moving on. So, with graphing, every time we've talked about graphing in Algebra 2 this year, we've talked about transformations of those graphs as well. Same thing here. We have transformations of our rational functions. So graphing translations of simple rational functions, which if you remember, the translations, we were adding or subtracting inside grouping symbols or adding or subtracting outside grouping symbols and all the other ones. Same thing here. So to graph a rational function of the form y equals a over x minus h plus k, you follow these steps. This is if you're graphing by hand. So I do want you to write down how to draw the asymptotes because I want your asymptotes to be perfect. So step 1, draw the asymptotes x equals h and y equals k. So h is your vertical asymptote, x equals h, and y equals k is your horizontal asymptote.
So we don't need to write this down because we're not graphing by hand?
You do need to write down step 1.
Oh, that's it?
Step 1, yep. Write down step 1. The rest we'll type in our calculators and sketch from the graphing calculators. Okay? You guys remember graphing horizontal vertical lines in Algebra 1?
No.
They're just lines that take the form y equals a number, x equals a number. So like we're seeing here. X equals h, y equals that number. Y equals k. H will be a number that you're given in the function that you're given. And k will be a number in the function that you're given. Yeah. So yeah, we graph our asymptotes first. So we're going to draw our asymptotes. We'll draw them as dotted lines because they're not actually a part of the graph. We're just showing that there's asymptotes there. And then we'll use the asymptotes and our graphing calculator to draw our hyperbolas, the branches of our hyperbolas. Okay? So everyone have that down. X equals h, y equals k. Can I move on? So, here we go. Graph g of x equals negative 4 over x plus 2 minus 1. So does this take the form y equals a over x minus h plus k? Does it take that form? Yes. So what does step 1 tell me to do? What does step 1 tell me to do that we wrote down on the previous slide? Draw the asymptotes. So I'm drawing the asymptote of x equals what? H. And y equals k. So, in this case, what is my h value? If it's x minus h, and I get x plus 2 over there.
2.
So you're telling me that's x minus 2 over there?
Well, no.
So it's not 2. If it's not 2, it's going to be negative 2, because if I plug negative 2 in there, they'd become x plus 2. Does that make sense? My h value is -2. What's my k value? -1. Everyone okay with that? So I'm going to graph those two lines as dotted lines. X equals -2, y equals -1. You may have learned it as Hoivux, how to graph horizontal vertical lines. If it's y equals a number, like we have over here, it's Hoi, because there's a y in it. What do you think the H stands for? Horizontal. So it's going to be a horizontal line going through which number? -1 on the which axis? Y-axis. So I find my y-axis, find -1 and put a point. What kind of a line did we say it's going to be?
Horizontal.
Horizontal. So I'm going to draw my horizontal line through that point. And there's my horizontal asymptote for my hyperbola. Okay? If it's x in a number, it's going to be Vux. Which axis do you think this is crossing? X-axis where? -2. So I put a point at -2 on the x-axis. What do you think the V stands for? Vertical. It's a vertical line going through that point. So I draw my dotted vertical line going through that point. And there's my vertical asymptote for my hyperbola. Okay? Any questions how I got my asymptotes? Now I've got to type it in my graphing calculator to see where the two branches are, and then I can draw my two branches using my asymptotes. Okay, so type that in your calculator. You may have to type it in very carefully.
Wait.
There's not a fraction button.
Type what in?
Type in our function that we're given. -4 over x plus 2 minus 1. So you may have to use some parentheses to get that division problem in there. So parentheses -4 divided by, use some more parentheses for x plus 2 minus 1. That's how I type it in, exactly like that. Exactly like that. Where are my branches? Where?
Top. The top one? Is it
Top right or top left?
left?
Top left. Based on your graphing calculator, it should be the top left, correct?
Then bottom right.
Bottom right. So I'm just going to use these asymptotes to draw my hyperbola. Does that make sense? Like I said, we're going to graph our asymptotes perfectly. Pocket or a bag? Okay, pocket or a bag. I want your asymptotes drawn perfectly. Use the graphing calculator to see where your branches are and sketch those in there.
Are we draw on the same graph? And we don't draw two different ones? Because I drew two different ones. You know what I mean?
I don't know what you mean.
Like, I drew one graph for the Wavelets one, and I drew another
No,
one.
they're on the same graph. Okay? One graph. Yep. What are you confused about? Did you type it in exactly like I put it on the board? Parenthesis, -4, divided by, parenthesis, x plus 2, parenthesis, parenthesis, minus 1. You typed it in just like that? Are there any questions how I got our domain or range here? So the asymptotes help determine your domain and range. Domain set your set of x values, so you use your vertical asymptote for your domain. You use your horizontal asymptote for your range because that's dealing with your y values. Okay? Questions on example 2? Can I move on? Example 3. Oops. So, does this function that I have, 2x plus 1 over x minus 3, take the form that it was talking about right here. A over x minus k plus x minus h plus k. No, it does not. So I'm not going to be able to just graph our asymptotes like we did on the previous example. I wish I would have put that on my notes.
Did you not take my notes?
I didn't, not very well.
Wow.
So, all rational functions that have this form, that's the form that's other than a over x minus k, x minus h plus k, these are still hyperbolas. But let me write down the formula for you for the asymptotes. So, you need to write this down. So, the VA stands for vertical asymptote. Is the line x equals negative d over c. So that's for my vertical asymptote. That's how I'm going to get it. The horizontal asymptote is the line y equals a over c. So you need to have those written down. Vertical asymptote is the line x equals negative d over c. Horizontal asymptote is the line y equals a over c. And those just come from the function that we're given. Okay? So, still kind of the same steps. We're going to graph our horizontal and vertical asymptotes, type it in our graphing calculator, and draw in our branches. Everyone okay with that?
Yeah.
So let's get our vertical asymptote first. X equals negative. What's my d value? What? Negative 3. Here's our form right here. Ax plus b over cx plus d. Our d value is negative 3. Over, what's my c value?
1.
1, my number in front of x. Very good. Is that all I needed to tell y'all? I think it is. Yeah. Okay. So I have, don't worry about that front negative first. Negative 3 divided by a positive 1 would give me what? Negative 3. And a negative 3 gives me positive 3. So my vertical asymptote is x equals 3. The line x equals 3. Everyone okay with that? So which axis is it crossing, this vertical asymptote? X, yeah, it's got an x in it, so it's crossing the x-axis. Where's it crossing it at? 3. And this is our vertical asymptote, so I'm going to draw a vertical line, just a dashed line through that point. There's my vertical asymptote for my function. Everyone got that? Okay, now let's find our horizontal asymptote. Y equals a over c. What's my a value, my number in front of my x in the numerator? 2 over, what's my c value?
X.
What's the number in front of x?
1.
1. 2 over 1 is? 2. So my horizontal asymptote is the line y equals 2. Which axis is this crossing? Y-axis where?
2.
At 2. Put a point at 2 on the y-axis. It's a horizontal asymptote, so draw your horizontal line through it. There's my 2 asymptotes. Any questions how we got them? Good? Now we can type this into our calculator. Everyone have these formulas written down in their notes. You need these. Vertical asymptote is x equals negative d over c. Horizontal asymptote is y equals a over c. You need to have those written down. Everyone got those? I'm erasing them. So I'm going to type it in my calculator, very similarly to that, like I did the last one. Do parentheses, 2x plus 1. Oops, never mind. No, yeah, that's right. Parentheses 2x plus 1. Close your parentheses. Divided by parentheses x minus 3. That's how I'm going to type it in my calculator, exactly like that. Where are the branches of my hyperbola? Top right, top left, bottom right, bottom left.
Kind of like in the center.
In where?
Like in the center.
Well, I'm talking about of the asymptotes. That the asymptotes cuts into 4 sections. Is it top right, top left, bottom right, bottom left? Top right, bottom left. And there's my hyperbola. Any questions on that? And then it asks us to state our domain and range once again. So raise your hand if you can give me my domain. Yep.
Infinity 3 to 3 infinity.
Negative infinity to 3. Does 3 get a bracket or a parenthesis? Parenthesis because it's not included. And you said 3 to infinity. Very good. Questions how we got our domain. Once again, we're using our vertical asymptote. It's going to be all real numbers except for the number that x equals. Because that's my vertical asymptote. It's never going to touch that number. Can someone else raise your hand and give me the range of this function?
Negative infinity to 2 and
Negative infinity to 2. 2
positive infinity.
to positive infinity. Very good. Once again, we use our horizontal asymptote to get our range. Not as bad as we thought at first. Hopefully. Okay with that? Can I move on to my last example?
Disappointed.
Okay, I'll take that as a yes. Rewrite g of x equals 3x plus 5 over x plus 1 in the form g of x equals a over x minus h plus k. Graph the function. Describe the graph of g as a transformation of the graph of f of x equals a over x. Whew, it's a mouthful. It's good stuff. So, how I'm going to rewrite this, if I've got a fraction, we've got a fraction here, right? Fraction's just division. Everyone understands that, correct? So I'm just going to divide these two polynomials using my long division. You guys remember doing that? Yeah, good stuff. Anyone remember how we do this? Okay, I'm looking at the first term of my polynomial outside, x. X times what would give me 3x? 3, so I've got to put my 3 up here. Then I've got to distribute my 3 through that polynomial outside. What's 3 times x? 3x. 3 times 1, 3. And what do I do with these two polynomials under the radical? Subtract 5 minus 3, 2. Those cancel out. So I've got a remainder here. You guys remember what we would do with our remainders? Yeah. So I'd get 3 plus 2 over x plus 1. You guys remember doing that? Put your remainder over your dividend, your divisor. Everyone see that? Is this now of the form a over x minus h plus k?
No. Wait, yes.
Yeah, I can just switch these two terms. Right? And now it's of the form. My a value is 2. We got x minus h, which is x plus 1, plus k. I got the plus 3. So, to rewrite it, we can just do our division problem. And that'll give me that form, a over x minus h plus k. Everyone okay with that? Okay, now we need to graph the function. How do we get our asymptotes if it's in the form a over x minus h plus k? What does x equal? H or k?
H.
H. So I get x equals what in this case if it's x plus 1? Negative 1. And y equals k. What's my k value? 3. So y equals 3. So I'm going to graph those two asymptotes. X equals negative 1. Y equals 3. Everyone good with where I got those? Any confusion at all? Okay. X equals negative 1. Which axis is it crossing? X-axis where?
At negative.
At negative 1. So put a point at negative 1 on your x-axis. It's going to be a horizontal or vertical line? Vertical. There's my vertical asymptote. Okay, y equals 3. Which axis is that crossing?
The y.
Y-axis where?
3.
At 3. Put a point at 3 on the y-axis. It's going to be horizontal or vertical?
Horizontal.
Horizontal. There's my asymptotes. We got those? Now type it in your calculator. See if you guys can do it on your own. Where are we getting our branches? Top right, bottom left. There's my hyperbola. Any questions on that? Anyone have any troubles typing it in the calculator? This is how I typed it in. Parenthesis 2 divided by parenthesis x plus 1, parenthesis plus 3. That's exactly how I typed it in. Careful there. Okay, so I rewrote the function in the form a over x minus h plus k. I've graphed the function. What do I need to do now?
Describe the transformation.
Yep, describe the graph of g as a transformation of the graph of f of x equals a over x. So what transformations occurred here? Well, it's probably just some translations because that's the only transformations we talked about. And we can get our transformations, actually, translations from these numbers right here. So did I go left one or right one? Left one, remember. We do the opposite of what it says if it's kind of inside grouping symbols. Inside the fraction in this case. Did I go up 3 or left 3? Up 3. If it's outside the grouping symbols, I do what the sign says. So I would say the graph of G is a horizontal translation. How many units in which direction do we say for the horizontal translation?
3.
No. Did I go left or right, and how many did I go? Left 1. So horizontal translation, left 1 unit. Followed by a vertical translation, how many units in which direction? 3 units up, or up 3 units. Of the graph of F. And there would be me describing the graph of G as a transformation of the graph of F. Any questions on that?
What about that 2?
That just affected the how far it's coming out from the branches, like the curve. But we're not going to worry about that. We're just going to worry about the translations. That's a good question, though. Any other questions? We good? Perfect. We'll get the assignment tomorrow in class.